All right. I feel like it's been forever since we did notes. Let's get a nice, let's do pink. Cool. All right, we're gonna start off our second little unit that we're doing. We're still in functions. We're gonna be hitting quadratics pretty hard today. Hopefully there's nothing today that feels like, wow, I never learned this before. This is like super hard. Why is it? All right, not off to a good start. Already zooming the wrong way. There we go. Hopefully it's nothing that seems super hard. We've seen it all before. We just kind of iron out some issues. Make sure we have some things kind of squared away that we've seen before, but maybe it was a little bit of a weakness or just a gap, maybe more than a weakness. Cool. Day 11. HL1, and we're going to be doing, I guess I'll write this on the next row, quadratics. I don't have this written down. I think it's 2.3. I think it's 2.3. No, 2.6. Sorry if I messed you up there. 2.6. No big deal. Quadratics. Now let's do, quadratics, right? What do we know about quadratics? Let's just shout things out. What are things you know about quadratics? What are you saying, Devin? It's what? Symmetrical. Sure. 2 M's, I'm pretty sure. Maybe I'm wrong. Symmetrical. Sweet. What else? X squared. I like that. What else? One minimum or one maximum. Okay. One. I'll just write the whole thing. 1 min or 1 max. Sweet. Fancy. What's the shape of it called? Parabola. Nice. What are things that is guaranteed to have? Okay. All real number domain. A y-intercept, yeah. If it's all real numbers domain, it's kind of the same thing, but I'm with you. Y-intercept guaranteed, yeah. Are we guaranteed to have x-intercepts? No, but we are guaranteed to have something that's kind of similar to an x-intercept. What do you say? Okay, vertex, that's a little bit different. But I'm with you. Vertex form, perhaps. Something we've looked at a little bit so far this year. Vertex form. Handwriting's getting worse and worse. What about, so we can't guarantee that we have 2 x-intercepts. But there's 4 words that all mean the same thing as x-intercepts. X-intercepts, zeros, solutions, and there's one more. Roots. And we are going to have 2 roots. You said that? I'm so sorry. I didn't listen to you just because you're not my favorite, but just kidding, Layla. I just didn't hear you. I'm so sorry. 2 roots. Anything else we know about quadratics? Is that everything we know? Sure, it has, more like a polynomial form. Standard form, it's kind of the same thing. Standard form, polynomial form. Either way, that's when it has the ax squared plus bx plus c. Yeah, I'm with that. Anything as far as quadratics? I know we have all real number domain, which is kind of going for this, but do we have anything, asymptotes, anything scary to really worry about? Not really. We don't have any real horizontal asymptotes. We don't have any, It's not really an asymptote, but we do have limits. Okay, I think it's good enough. I think that's plenty of things that have to do with quadratics. We're going to start, and we're going to kind of, I guess this is the one that I kind of came up with, but we're going to start, we're going to focus on this 2 roots. And again, I hope that we know this information, but we're going to make sure that no matter what quadratic comes your way, you can find the 2 roots. So that you can't possibly run into some sort of, roadblock. So let's start. And we're just going to do this for a couple questions. Let's find both roots. That's just the rules. All right. The first function let's look at is x squared minus 8x plus 7. Find both roots. We're going to go easy to hard, so this should be the easiest one. How are we pushing forward? Factoring. Sweet. It's polynomial. Hopefully we can factor it. And can we factor this one? Sweet. What are the 2 factors that we get? What is it? X minus 7 and x minus 1. That's right. Those are not the roots. Those are the factors. How do we get them into roots? Set them equal to 0. So our roots, x equals 7, x equals 1. And something that we lost a couple points on for the test, what if I said, coordinates? Tell me the coordinates of the roots. How can we write this as a coordinate? Right, which would be 7, 0 or 1, 0. Sweet. Now, for this question, I don't really care about this, but I just want to, we just had the test, and some of us, it said write the coordinates, and we didn't write the coordinates, so we lost 1 point. Or it said, do this, and we didn't. So just kind of think about that. Cool. Anybody nervous about factoring questions like this? You definitely, when we get to these tests and quizzes, like, if you're missing factoring points, your score is going to slip away from you a little bit. Those are points we need locked up every time. Number 2, f of x equals 6x squared minus 13x minus 5. Handwriting. There we go. What's the only difference here? There's an a, there's a number in front, and that doesn't really change too much except for our super mega easy factoring strategy kind of falls apart a little bit. And we need some sort of more in-depth factoring strategy. And there's a lot of them out there. There's slide and divide. There's grouping. There's guess and check. Does everybody feel like they have a strategy to do this question? How do we like to do it? Do we like to do slide and divide? Do we even know what the name is really? Okay, bring the 6 to the 5. Negative 30, like that? Okay. Sweet. Negative 30, and then what do we do? Right, it's going to be negative 15, positive 2. I agree with you. That's how we get negative 13 with multiplication and negative 13 with addition. But this doesn't work because x times x is x squared, not 6x squared. And so this is where the sliding and dividing part shows up. I guess sliding was the first part. Dividing is the next part. Divide by 6, both sides. This is 15. Come on, my bad. I was like, help please. Easy. 15 divided by 6, they both reduce by 3. it's going to be 5 over 2. Put the 2 in the front and the 5 right there. Over here, this is going to reduce by 3. It's going to be 1/3. Put the 3 in the front, leave the 1 there. Sweet, we factored it, but our goal is not to find factors. Our goal is to find roots. And so what are the roots? 5 over 2. Negative 1 over 3. Feeling good? Sliding and dividing. Got that locked down. We need those points. Feeling good? Let's sneak one in here. All right, this is the Algebra 1 killer. I'm sure we can handle this. F of x equals 5x squared plus 2x. That's it. This one's different because we're missing a c value. How do we handle it if we're missing a c value? If we replace it with 0, that's probably making the whole thing harder. There's a super easy, done in 2 seconds strategy here.
Yes, you can do that
GCF, right? If the c is gone, then everything has an x. Awesome. And if everything has an x, then let's take that out. Now, 5 and 2 don't have any number or digit or integer GCF, so we're just taking out the x. And so, great. We've already factored. The question's basically over our roots. X equals 0 and x equals negative 2/5. That's a killer in Algebra 1 because the kids just forget about GCF. But I'm sure we're never going to have that problem there. Okay? Feeling good? Cool? So we've done questions with a equals 1, questions with a not equal 1. We did questions where c was 0. Let's do a question where b is 0. F of x equals x squared minus 9. We're missing the middle piece, b, the piece with a single x. Well, how are we going to solve that? Right, so there's actually 2 strategies. Let's do this one first. This is a great one. This is a perfect, nice difference of squares. It's a pattern that we can learn. You take this first piece and you basically just split it up, x and x. You take the second piece, 9, and you make it 3 times 3. And you make one of them a minus, one of them a plus, and we're in good shape. Our final answer would be x equals 3 and x equals negative 3 for our 2 roots. Now, a couple things that I just want to kind of throw at you when we're here. This, without a b value, is in what form? It's kind of looking standard, but it's also in this vertex form. We don't really see it that way because our brain is right now working in, this is a polynomial, but if we think about it like this is our vertex form where the number inside with the x moves you left and right, and the number outside moves you up and down. This is a plain old x squared, which is quadratic, that has been shifted down 9 units. Something like that. And its 2 intersections are going to be negative 3 and 3. Right? So this is also in vertex form because there's no b unit, because all the x's are consolidated into one piece. Now, let's do a very similar question. F of x equals x squared minus 10. All right, well, thinking about it in vertex form, it's basically the same thing. We're just down 1 extra little tick. But how do I find my roots for this question? And we could use a calculator, but no calculators allowed. Any ideas how to do that? What do you got, Devin? So you're on the right track, yes. Or basically you're 100% correct. But the way I'm going to explain it is all of our x's are consolidated into one stack. Quadratics, when they're difficult, you have the x squared stack and the x stack, and you have to figure out some kind of way to handle with that issue. But for these questions, there's only one stack. So if there's only one stack, then you can just set it equal to 0 and solve it like a math equation. Because there's only, again, the reason we're allowed to do this is because there's only one term with x's. So we add 10 to the other side. X squared equals 10. And then we square root both sides. X equals square root 10. And that is half of our answer. Where's the other half? Plus or minus. Whenever you square root both sides, you need to include this, plus or minus. And so there we go. Those are our two roots, positive square root 10 and negative square root 10. And it's the same exact thing, right? If I just take this exact painting here and I just copy it and I bring it down here, and then I take my quadratic and I move it down a little bit, it means that these dots will need to go a little bit wider. And the square root of 10 is like, I don't know, 3.17 or something, 3.2. It's just a little bit wider than 3. So great, everything's working out great. Things are moving great. Any issues with these two? Now you can do the same thing for this one, by the way. You can add 9 and do the square root of 9, plus or minus. But of course, the square root of 9 is 3. So you get plus or minus 3. So what happens? What happens if you have something like f of x equals x squared plus 11? What are you saying? Nice. And if we wanted to be a little bit annoying, what is a better name for imaginary? Okay, then we'll hold on to that thought. We'll do that in a second. Equals 0. Why is it imaginary? Well, we're going to subtract 11 the other side. X squared equals negative 11. Is there any number that when you square it, you're going to get a negative? No, of course not. You square root both sides. X is equal to plus or minus square root negative 11. That's a problem. There's no way you can take a square root of a negative. And so I agree. We're getting an imaginary result here. X equals plus or minus I square root 11. Anytime you have a square root of a negative, it counts as an I. So you can take that negative and just throw it outside for an I. This is imaginary, but a little bit fancier. Maybe not fancier, but complex. Okay, a complex number is a number that's like part imaginary and part real. We'll talk a little bit more about complex. Most of the time, if something says like find the imaginary roots, it wouldn't say that. It would say find the complex roots. So I'm just trying to associate the word complex with imaginary. For this question, this entire piece right here, there's only one piece and it has an I. So the whole piece is a whole imaginary piece. And so imaginary does work great because there's only an imaginary piece. But lots of questions that we'll do for the rest, or we're only going to do a couple more, but other questions we do today are going to have a real piece and an imaginary. And for those, it has to be considered complex, being real and imaginary. I guess I'll write this on here. Real and imaginary. But again, solving these, not too hard. Hope we're not having a ton of issues. If the x is consolidated into one pile, we're handling that, no problem. Moving on. What if we have f of x equals x squared minus 7x plus 2? first try. Can we factor it? It's not looking so good because 1 times 2 is 2. There it goes. 1 times 2 is 2, and 2 factors of 2 that add together, no way. It's not going to happen, right? 7's too big in the middle. Factoring is a bust. Try number 2. Can we just set it equal to 0 and just start going for it? No, because we have 2 piles of x's, and that we're not really going to have a way to get those shoved together. Really kind of like lost algebra would be subtract 2 the other side and do a GCF on this side. No, you can't do that, right? We're stuck, 2 piles of x's. We can't really go there. And so what is our last hope? Quadratic formula. So let's do the quadratic formula. The quadratic formula is x equals big fraction negative b plus or minus the square root of b squared minus 4ac over 2a. How many of us have the quadratic formula memorized? Anybody want to say it? Love it. Nice job. Sweet. Very good idea to memorize it, but is that formula in your IB packet? A couple people shaking their head. The truth is, does Mr. Collier know for sure? No, he doesn't. So let's... You want to try to find that in there? All right. A, B, and C come from the start. If I was teaching Algebra 1, I'd say A equals 1 and B equals -7 and C equals 2, and then make sure they go where they're supposed to go, especially the negative numbers. X equals, what do you say? Yes! But we shouldn't need it, right? Awesome, it's in there. Great, we have no excuse to ever get it wrong. The number out front is a 7, a positive 7, because -7, negative b, 2 negatives makes a positive, plus or minus the square root of b squared. Any number squared is always going to be positive, so even though it's a -7, it's going to end up being positive right there. Minus 4a, which is 1, c, which is 2, all over 2a, which is 1. X equals 7 plus or minus square root 2, and inside that square root is going to be 49 minus 8, which is going to be 41. We cool with that? Great. Awesome. Now, just because they like to get cheeky sometimes, and I know that I'm kind of envisioning in IB questions, it seems like the ones where it says, of the form A, B, C, find A, B, C. I feel like those are questions we kind of struggle with and stuff. So let's just imagine this, okay? Imagine I'm just gonna teleport you to an IB style question here, okay? I'm gonna say part A. If roots can be written in form a plus or minus b square root c, find a, b, c. Right? So I feel like this is a style that we've gotten wrong a couple times on quizzes and tests. We've already found the roots. They're right here, but they just want it to kind of be styled in this way. A plus or minus b square root c. One of these is super easy. Which one of these letters can we just go really quick? C. C is 41. Nothing's going to change this c. It's in the square root. There's nothing that has the power to get in there to that 41. That 41 is locked in. But A and B are not as straightforward. Up here, I see that we have 7 and 2. Is A 7 or 2? Is B 7 or 2? Anybody got any guesses? Does anybody know the answer for this? What do you got, Devin? You're shaking your head. A is 7 over 2, B is 1/1. Yes, A is 7 over 2, and B is 1/2. Now, where the heck did those numbers come from? On the top, we have two things. And on the bottom, we're dividing everything by 2. So the question here said, please have this written without a fraction, which basically meant, or not without a fraction, without a big fraction. So we just said, okay, we'll give you 2 little small fractions. We gave a 2 to the first term and a 2 to the second term, and that's how we got this question.
On tests and quizzes, do you want it in a big fraction, or do you want it in the...
An interesting point. On tests and quizzes, do we want it in the big fraction, or do we want it written in 7/2 plus or minus 1/2 square root 41 form? Here's what I would say. If the question says find a root, find the roots, so there's gonna be 2 of them. Boom, we found the roots. Stop doing stuff. The question's over, you did it. In this class, we're gonna get our test back in a bit. We kind of had the issue of like, the question said, hey, find me the line. And a lot of you made a point slope form, which was great. You're done. But then you tried to take that point slope form and make it into slope intercept form. Why are we doing that? They didn't say like, tell me a slope intercept form. They just said, tell me a line. And so you were kind of already done. So what I would recommend, Devin, is read the question. If the question says, give me the roots, and you've got the roots, done. The more you do this, maybe you goof, and then you lose points for free because you already had it. So I would just say, when you're done, you're done. Cool? Very good question. I'm glad you asked that because that's one thing, especially with the lines, like I said, we were going to talk about in regards to the test. Okay, we're doing pretty good. We are sort of near the end. We'll see. F of x equals 6x squared plus 4x plus 3. Can we factor it? Who's the fastest factorer in the class? Can we factor this? 6 times 3, 18, positive 18. I don't think it's going to work. It needs to be 2 numbers that add together to make only a 4, but multiply to make 18. It's not going to work. There's no way. So we lose. We have to use quadratic formula. So let's go quickly here. X equals fraction 2a on the bottom. That's 12. Negative b out front. That's negative 4. Plus or minus square root b squared. 16. 4ac. 4 times 6 is 24. Times 3 is 72. Because 24 is almost 25. And 25 times 3 is easy. That's 75. Boom. I did a lot of that in my head, but I feel like we're getting sick of doing this kind of algebra, so we're just flying through it now. What is 16 minus 72? 16 minus 10 is 62. Or sorry, 72 minus 10 is 62. And then minus another 6 from 62 would be 56. Negative 56. Why did this question get its own? What's the point of doing this? We're here, and we have a negative square root. Dang it. This is a huge bummer. Okay, we have our negative square root. It's not really all that big of a deal, all right? The negative square root is just an I. It's just giving us a complex number. Specifically, we kind of need to upgrade to complex here because this 4 is just a plain 4, and it is not going to get the I. So this is a normal old integer 4. This is going to be, what is that, 2I square root 14 over 12. 56 is 2 times 28, which is 2 times 14. Those two 4s are going to make a 4, which is going to bring a 2 out front. Negative inside the square root is going to bring an I. That's just simplifying radicals. We made it this far, And this is probably one step short of how far we need to go because we can simplify this. We have 4, 2, and 12. All of those numbers can be simplified. They all can be divided by 2. Importantly, square root 14 is excluded from this because that is a square root number. It does not mess around with the normal numbers. So, probably best way to write this, -2 plus or minus just an I, square root 14, don't touch that, over 6. There are your 2 roots. These roots have imaginary parts to them in combination with real parts, making complex. So this is a complex root. Now, graphically, how does a complex root look? If we think where we started, 6x squared plus 4x plus 3, all right? And imagine that I just told you you're not allowed to look at your calculator, but you have to sketch this for me. How much can you pull from this information here? First of all, do you know if it should be an upwards parabola or a downwards parabola? And why is it up? Yes, we're looking at the A, and I see the A is positive, so we're going with an upwards parabola, okay? Now, when we're talking about roots, does it have real roots? No. That means it's not allowed to touch this. I'm not saying it's an asymptote, but we're not allowed to cross that x-axis at all. And so if we have to be an upwards u, that is not going to work because we're not allowed to cross. So this, anything up here is a valid guess for how it's going to look. Complex roots basically just mean it doesn't have any x-intercepts that are real. It's just a graph that's either an upwards one up above or a downwards one down below. Sure. That's another great thing we could come up with. Now, I don't know if it's a 3 like that, or 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 a 3 like that. But yeah, that's great, right? You could also, all things that we can analyze looking at this graph. I like that. Nice shot. Okay, let's talk about how can I give you this function and I say, oh, don't do that. Here we go. And I lock you in this classroom and I say, all right, you have 30 seconds to tell me if this has real roots or complex roots. And if you don't get this, don't tell me right in 30 seconds, you don't get to leave school. You got to stay here all night. You don't get to go home. What is the fastest way to try to identify whether this is going to have real roots or complex roots? What are you saying? Yes, the quadratic formula, which we had to use, but specifically like he's saying, if we're doing the whole quadratic formula, but all we want to talk about is, does it have real or complex? Does this 4 really matter? No. I mean, it's important for the real thing, but if all we want to know is real or complex, who cares? Does this 12 really matter? No. The only thing that really matters is that inside of the square root. And what is that called? Does anybody know the fancy name for that? The what? I hear what you're saying. I thought you were saying ratatouille for a second. Just kidding. Inside the square root of the quadratic formula is something called, we probably should have known this, the discriminant. Is it coming back? The discriminant. You will eventually get a question that says, find the discriminant. So if that's something that you kind of forgot about. And also, the discriminant is the inside stuff. It does not include this square root. So don't tell me, hey, what's the discriminant? Don't tell me it's the square root of 5. No, no, no. It's just 5. You guys see what I'm saying? The discriminant is not including the square root. So what we just talked about. We've got the discriminant. What are the combinations of letters that make the discriminant? You got it. Perfect. B squared minus 4ac. I appreciate you volunteering. That's awesome. B squared minus 4ac. And not the square root. Very good job. Just b squared minus 4ac. What happens if the discriminant is positive? What are the results of a positive discriminant? Love it. What if it is negative? What do you say? No. Me being a punk, but not imaginary, complex. Again, that is mostly just me being weirdo stickler math teacher, but you know what? You're an IB, so I guess you get a couple weird teachers. Now, what is the other option? Discriminant is positive, discriminant is negative, discriminant is 0. What the heck happens if our discriminant is 0? Anybody know? Are we stuck between the bounds of real and complex numbers? Okay, I'm gonna pretend like I don't know either. Let's try to figure out. We're gonna go to build a function factory here. G of x, ax squared plus bx plus c. And let's make our own function here that has a discriminant of 0. Let's make one up, okay? If we want our discriminant to be 0, then what do we want? B squared minus 4ac equals 0. And that just means you got to pick 3 numbers that makes this happen. Which one are you starting with? Is that A or B or C? Okay, so I see what you're saying. 2, and then you said 1, 1. Can I get a second source to verify that that makes 0? 2 squared is 4, minus 4 times 1 times 1. 4 minus 4 equals 0, boom. Will this work? Yes, that would be the function 1x squared plus 2x plus 1. What are the roots? Are we going to factor it? Are we going to go to quadratic form? How are we going to do this? Factor, okay. If we're factoring, it should be pretty quick. What are we getting? Oh, let me move this a little less far out of the way. Correct. G of x equals x plus 1, x plus 1. What are our 2 roots? Our 2 roots are x equals negative 1, and what's the other one? Also x equals negative 1. Bless you, Gesundheit. Okay, so what happens if the discriminant equals 0? What do you guys think? I'm with you. If the discriminant is 0, how many roots are we going to get? It's always 2. But it's only 1, but it's 2. We're going to have... Stop. Please don't delete. We're going to have repeated root. And that hopefully makes sense in English, right? We had negative 1 and negative 1 again. We had a repeated root. You should have learned, again, I hate being the guy who always says you should have learned this before, but I really am not super comfortable with like what you guys know and don't know. Have we ever seen repeated roots before? Graphically, how does a repeated root look? You guys are obviously both correct. We need to cross right here and right here again. So basically we try to go through the x-axis and we go through it, but then we go through it again. And it, in reality, is a perfect bounce on the x-axis, just like Grady and Devin were getting to. So that's how a repeated root looks. So if your discriminant is 0, you get a repeated root. Now, let's think about that for a second. If this is our formula and we get a 0 in the square root, that means that this whole thing is 0. Also, this is where our 2 terms come from, but it's a 0, which means we don't get 2 terms anymore, we only get 1 term. That's why we get the same thing twice, because it's plus or minus 0, who cares? Everything stays the same. Okay. Doing all right? We know how to handle square roots. We know how to quadratics. All this. We're doing okay? All right. We've been crushing today. We got to do one more thing. We're not done yet. But I promise we'll go quickly. And I'll be honest, here comes probably the hardest thing we've done all day. Even though, again, the best of my knowledge, you already know how to do this. Complete the square. Now, this is a tool that you want to know how to do, okay? It's not a tool, like you might not need it. In fact, on the homework tonight, I don't think you need to use this on the homework ever, but you still want to be a math student who knows how to do this. I coach soccer and I played in college, and students, players all the time, oh, what do I need to know how to do in order to play in college? And obviously you just need to be a good player. But there are other things that, do you really need to know how to do them? Or is it just good if you're a soccer player that can do it? Like soccer players, you can juggle where you keep bounce the ball on your foot. And is it a good thing if you can do that 100 times in a row? Yes. Are you going to do that in a game? No, but it's just something you want to have in your back pocket. And that's what completing the square is. Completing the square is used to turn standard or polynomial into vertex, which can be very useful. Vertex helps us graph without a calculator. Unfortunately, completing the square can be a headache. If you've been zoning out or bored, lock it in. Here we go. This is where we're going to move. I'm going to try to move quickly because I don't want to drag this out too long. X squared plus 6x plus 5. I want a perfect exact graph of this function. You have 3 minutes and you can't use a calculator. Well, dang, right? Dang. I don't, where can we start? Oh, I can factor this, right? Boom, I factor it, x plus 5, x plus 1. X equals -5, x equals -1. What does that do for me? What do you say? No. Those are the roots. Those are the intercepts. Boom, -1, -5. But my graph could look like this, or it could look, well, I have to redraw it every time. But there's many, many graphs that could go through there. That is decent, but again, I want a perfect exact graph. And this is the easiest example we're going to do. Let's get it into vertex form. And the way that you do that is you want to try to build this kind of thing where in here is a binomial squared. That's why it's called completing the square, because you want to build kind of artificially a nice repeated root kind of thing. You want to build that x plus 2, x plus 2. You want to build that x plus 3 kind of thing. So what we're going to do is when we build this, we're going to treat this k as the junk. And in here, this is gonna be our perfect. Okay, that's how you have to kind of envision this. On the inside, we have to be very specific and build this perfect little balance. On the outside, who cares? It's the junk, just get it out of there. So here's how we're gonna do that. I guess I'll leave that and I'll just scroll down a bit. We are going to write out our original, x squared plus 6x. Then we're gonna leave a gap for two numbers and then a plus 5. Okay? So you have like a gap in your paper. I guess I'll use white in between these purples, pinks. This first number is the perfect number. And the second number is the junk number. The perfect number is gonna make this nice side over here two perfect binomials that are exactly the same so that we can write it like that. The way we do that is we look at the middle number and we think if this is gonna be x plus something that's exactly the same squared, then this, it's gonna end up being half of that, 3 plus 3. So we look at this middle number b, we cut it in half, and then we square that, or we multiply it by itself. It's all the same thing. So with 6, we're gonna think, okay, 6 is 3 plus 3. In order to finish the combo, we need a 3 times 3, and we're gonna add 9. And this has made a perfect pattern, because how do you factor x squared plus 6x plus 9? X plus 3, x plus 3. We can put those together and it would look like this. Now, we have to sort out the junk that is afterwards. And we're not allowed to just add a plus 9 to a question, right? You can't just show up to the IB test and just say, I'm gonna put a plus 9 on this question and ooh, what are you gonna do now, right? If we do that, plus 9, what junk do we also have to add? Minus 9. And so what is our k value gonna be? Right, -4. And now we're in vertex form. Perfect. If I wanted an exact graph, not only do I get the roots, but this way I even have the vertex, which is -3, -4, -3, -4. Boom, go through my 2, and now I'm able to get such an easy graph. And really, this isn't a super long process. You can go through it quite quickly. But I've been talking forever, so let's just keep going. What if we have, again, trying to prepare us so that we can handle anything. What if we have a function like 2x squared plus 8x minus 5? Can we factor it? 2 times 5 is 10. No, not factoring it. But I don't really need to factor it. I want to get it into vertex form. Sweet. Let's switch this up. K of x, 2x squared plus 8x. Give me some room for two numbers here. Now they're going to be the same number, a plus 9 and minus 9, or something like that. So we only really need to figure out one number, and then just put its opposite there. This question has another problem. 2x. So actually, we're going to need to do a GCF. We're going to need to pull out that 2. But we're not going to pull it out of the whole thing. Just out of that first piece. Because that first piece is where we're trying to make everything perfect. Who cares about the junk? All right, look at this, it's easy. Cut it in half, what's half of 4? 2, then square it, 4. So we're gonna add 4, and how much are we gonna subtract? Careful, It's not 4? 8. Nice. It is 8. Why the heck is it 8? It's supposed to be the same number. Because you have to be careful. The 2 here is affecting this 4. You've actually added in 2 4s, which is why you have to balance it with a negative 8. So our vertex form for this question is 2x plus 2 squared minus 13. And to finish the notes, God, the notes that will never end. But as soon as we're done with this question, you can handle any quadratics ever for the rest of your life. Let's say that we have, as ugly as it gets, oh boy, g of x equals x squared plus 5x minus 4. Why is this one the ugly one? 5 doesn't divide by 2. But we can still do it, right? We're IB kids. We're the best kids in the whole freaking city. Yeah, we can still do it. X squared plus 5x. Leave 2 gaps, minus 4. 5 does actually get divided in half. It just is a fraction, right? So take 5, cut it in half. It's just going to be 5 over 2. But that, I mean, that's not hard. It's ugly, but it's not hard. And then square it, and that's also not hard. It's hideous, but it's not hard. When you square this, you just square the top, which is 25, and you square the bottom. Oh. And you square the bottom, which is 4. Add that here, subtract that here. And now we will get to our answer, or our vertex form, I should say. That, 5 halves is what goes in there. And on the outside, the junk is looking extra junky. That could be 16 fourths, negative 41 fourths. And that's awful. Again, I wouldn't touch that. If you're thinking to yourself, ooh, can I do the slide and divide thing and move that too? I wouldn't mess with that. That's gonna make things even more complicated. It's ugly. It's probably gonna be ugly for the rest of its life. Just let it die ugly. You know what I'm saying? Just leave this thing alone. It's gonna be okay. All right, quadratics. We can factor them. We can use the quadratic formula. We can even complete the square. We know what discriminants is. We're done. Last call for comments? Sick of it? Sweet.